So to help you out here and kind of help you illustrate what's going on with the neutralization formula, let's work a very simple problem. And in this case, we're going to take a 3 molar sulfuric acid solution and react to 100 milliliters. And we want to know how many grams of aluminum hydroxide that could react with. Or another way I could ask is how many grams of aluminum hydroxide are required to neutralize 100 mLs of a 3 molar H2SO4 solution. Now, previous video I showed that there are 3 forms of the neutralization formula, 3 practical forms. Polarity of the acid, volume of the acid, coefficient of the acid, moles of base, coefficient of the base. Moles of the acid, the coefficient of the acid, equals the molarity of the base, volume of the base, coefficient of the base. And the final one, molarity of the acid, volume of the acid, coefficient of the acid, equals molarity of the base, volume of the base, over the coefficient of the base. And we proved where this comes from. Now, which of these 3 forms do you work with? Well, the thing here is the phase. So if we see an AQ here, if there is an AQ on this and we're not told that this is a solid dissolved, because there will be problems where I say, oh, how many grams of this, knowing that we're going to be dissolving it. If you know your acid is aqueous, meaning you're given a molarity, you're going to want to work with the MA/BA formula. So we're not going to need this case. Now, what about the base? Well, we're not being asked for we're being asked for the mass of the base required. So if you're being asked for a mass, and furthermore, if you actually see a solid up here, this tells you you're not working with an MB/BB formula. So this is the equation we're going to be working with. How do we use it? Well, again, we're being asked how many grams of aluminum hydroxide are required in order to react 100 mLs of a 3 molar H2SO4 solution. So put in what you know. This is, switch to a different color here. We know that we've got a 3 molar H2SO4 solution. We have 100 mLs, but the thing to keep in mind here is that we only have volume on one side, so we need to work in milliliters. And this new here is going to come from the reaction. So we get 3 times 0.1 over 3 equals our moles of base divided by the reaction coefficient of the base. The reaction coefficient of the base is going to come from the reaction, so it'll give us a 2. So we get 3 times 0.1 all over 3 equals our moles of base over 2. So this tells us we have 0.2 moles of AlOH3. How do we get grams? So hopefully you know how to do this by this point if you're looking at this video. All you're going to do is take your moles of aluminum hydroxide and convert it to grams of aluminum hydroxide. So this is how you work with a neutralization problem. If you know the phases of your material, specifically your given concentrations, you're going to be working with the molarity volume form of that in terms of moles. If you're asked for grams of something, odds are you're going to be working with the moles component of it. The bottom part here of the neutralization formula is going to come from your reaction. The top part here is going to come from your experimental conditions. And that's how you work with the neutralization formula.